Welcome to the first part of the day 2 of the randomizer lesson. So in the randomizer project, as a review for those of you who are just joining us, we first wanted to create a set of methods that would describe what any randomizer, a randomizer will be a object that we've created that we can use in the context of a game to introduce randomness to the game. Common randomizers that exist in the real world are things like a coin, dice, spinners, or a deck of cards, just to name a few. So what we did is we said that there are some aspects that are common to all these randomizers. One is that we find out easily how many possible outcomes they have. And as an example, a coin has 2 possible outcomes. A die, of course, has 6 possible outcomes if it's a standard 6-sided die. A deck of cards has 52 possible outcomes, 1 for each card. A spinner, well, it would totally depend on the spinner. Okay, so what else? What other methods would a randomizer have? A randomizer would also be able to return its current value as a number, because we're programmers and numbers are going to be easier to work with. So we always want to be able to get the current value in the form of a discrete numerical value, which means that we're going to use an int as our return type. And then, of course, we want to get a more user-friendly version of the output, which is what we're calling the face of the randomizer. So if it's a coin, the face is the side that's showing on the coin, heads or tails. If it's a die, a standard die anyway, it would be the numbers 1 through 6. If it's a deck of cards, it would actually say what the card was: ace of hearts, 2 of diamonds, queen of spades, etc. All right, and then we have a final method that falls into a category we call a setter or a mutator, which causes our randomizer to actually generate a new random value. A way to think about this is it would be like telling a coin, okay, now it's time to flip the coin, roll the die, spin the spinner, or draw a card from a shuffled deck. Okay, so what did we do next? Well, we decided to create a coin object as our first simple randomizer. Now, a coin object is a class, and it's important to make the distinction between a class and an object. When we talk about creating an object, we're talking about actually using or instantiating a class, which we'll get to in a moment. So right now we're talking about creating the class coin. A class can be thought of as a blueprint, and in this case we're saying that our coin is going to implement the randomizer interface. What that is a contract that says, because we're a randomizer, you know that we will have all of the methods listed in the randomizer interface. There will be a get possible outcomes method, a get current value method, a get current face method, and a randomize method. Next, of course, we want to have those methods. But before we get to that, we need to talk about the anatomy of what you find in a class. One of the things that you find is something called instance variables. Instance variables are variables that are declared in the AP subset. They're always marked with the keyword private, which basically means that those variables are only accessible within the class. What makes instance variables different than local variables is that they have a scope that is the entire class, which means you can use these variables in all the methods within that class. So we declared a Boolean variable to keep track of whether or not heads was the current thing that is showing for our coin. The next thing that we have is what we call a constructor method. And this is a particular kind of constructor method. Because it has no parameters, it is called a default constructor. All objects, all classes, or rather all classes that can be objects, have a default constructor. If you don't write one, Java will create one for you. So, what is a default constructor? And what is a constructor generally? The job of a constructor is, among other things, to get your object completely ready to be used. Think of it if this is a blueprint for a coin. When we call the constructor, we're actually stamping the coin. So what does that mean? Well, first, the constructor must be public, otherwise you wouldn't be able to call it. And a constructor always has the exact same name as the class itself. And then finally, it's a method, so it's going to have parentheses. Now, what does our constructor need to do? Well, in the case of a coin, it's very simple. We want to initialize isHeads as having the value either true or false. We did that by calling the randomize method because we want our coin to start off with a random value. Well, that means that we need to jump down to the randomize method. Now, notice that we just call the randomize method here, and because we're just saying the word randomize, we're just calling it the method with nothing else to clarify it, this method must be a method within this class. Okay, so what does the randomize method do? It assigns a value to isHeads based on taking math.random and determining if that value is less than 0.5, which it should be exactly half the time. Therefore, isHeads will be true half the time and isHeads will be false half the time. So, has our constructor done its job? Has it initialized our instance variables? The answer is yes. Therefore, our constructor is done and we return. What other methods does our class have? Well, we need to get the possible outcomes or be able to return a value for get possible outcomes. In the case of coin, there's only two options. It could be heads or it could be tails. And then finally, or next, we want to get the current value. Remember, this is a sort of tool for programmers, so we're going to return a numeric value, and we've decided that heads will have the value 1, tails will have the value 0. Obviously, this is an arbitrary decision we as the programmers have made. Next, we're going to get the current face of the coin. The face is a string value that describes what you see if you look at the coin. Well, if heads is showing, then we want to return the word heads. If heads is not showing, then we simply return tails. And we've already spoken about what the randomize method does. So, how does all of this get used? Well, in CoinRunner, we use it by first instantiating a coin. Instantiating an object follows the same pattern for declaring any other primitive variable with one slight twist. First comes the type of the variable. In this case, the type is the class coin. Then I have to give the variable a name, my coin, and then I use equals to assign it an initial value. In this case, the way I give it a value is by calling the constructor. Notice that this looks like the class name, and it does match the class name, but it has parentheses after it, which means we're actually calling the default constructor right here. And it's worth noting that a constructor is unique because it doesn't appear to have a return value, return type. And that's because the return type is the object itself. Notice we're saying equals new coin. What is being assigned to coin? An actual instantiated, ready-to-use coin object. Okay, then we decided to print out the value of that coin as a string using the getCurrentFace method, and we access methods within an object by typing the name of the object dot then the name of the method that we want to call. Next, we decided to loop through 10 times, randomize the coin each time, again by typing the name of the object followed by the method we wanted to call, which was randomize. Then we printed out the new face that was generated randomly, and we used the getCurrentValue method to determine if that was a heads that was showing, and if we did, we counted it, and when we were done, we printed how many heads we actually saw. If we run this little program, we see that we got an initial value of heads. Then the next time the coin was flipped, we got tails, then heads, tails, heads, and then a whole bunch of tails. If you count how many times tails showed up in this sample run, you can see it's only 2, so our program has in fact worked. Okay, so for those of you who are joining this lesson late and didn't follow the day 1 code, if you're missing any portion of this code, you can download the project in Eclipse form from the website in its entirety and start off with this exact code before we begin modifying it for this lesson. In this lesson, what we're going to do is we're going to learn about a few new advanced items that come along with object-oriented programming. The first one is something we call inheritance. Now, inheritance is something we're going to go to in much more detail later, but for right now, what you need to know is that when we created a class called coin, we inherited all of the methods from Java's object class. All objects in Java automatically inherit from the object class unless they inherit from a specific other class. And whatever class they might inherit from, that class will eventually trace its lineage all the way back to the object class. So all objects in Java can be said to be descendants of the object class. Well, what does that mean to you? Well, let's perform a little experiment here. Let's go to our coin runner. And instead of printing the current face here, let's just print the coin. Now you might think, why doesn't that generate a syntax error? I'm not calling any method, so what's going on here? Well, remember that when you combine 2 different types in an expression, Java will do automatic type conversion. So what has to happen to my coin? It has to become a string. Well, how does that happen? And it's an interesting example of what actually happens, because the way that occurs is through the mysterious power of inheritance. Notice the initial value of my coin is coin at, and then this interesting number. First of all, that number is a hexadecimal number. We know that because it's got the decimal digits and it's got letters ranging from A to F. Therefore, it's likely to be a hexadecimal number. This is something we call a hash code, and it's a unique identifier for this object. Now, is that very useful to the user to see coin at and then some sort of gobbledygook number that they don't probably understand? And the answer is, of course, no, that's not very helpful. But where did it come from? And the answer is, when my coin was converted to a string, the method called toString, which converts every object into a string, was automatically called. But wait, you say, I don't see a toString method anywhere in my class here, so where did it come from? And the mysterious answer is, it was inherited from the object class. And we can see that if we go back here and we type myCoin toString. Look at that. We could see the Java doc for the toString method. Now, if you read this, it tells you that it returns a hash code in the form of a hex string. It spells out exactly what the toString method does. Where did it come from? It came from the object class. Our object inherited this method from the object class. Well, you say, well, that's nice. That's all very helpful, but I don't want my user to see that. I would prefer for them to see something a little bit more friendly. So how do I do that? And the answer is, I do something called overriding. So I'm going to override the inherited toString method from the object class. How do I override? Well, first I'll spell it correctly. How do I override a method? Well, I simply replace the method with one of my own making, and I do that by filling in the method signature and then writing the code for what I want it to do. Well, what do I want it to do? I would like it to instead simply give me the current face. So I'm going to call the getCurrentFace method. Now you may ask yourself, that seems silly. Why am I going to all this trouble? And you're going to see later on that there's some real power to overriding the toString method. Also, there are some real benefits to calling another method rather than just repeating the code. Couldn't I have just put this code in again? Sure, I could have, but by doing this, I make it so in the future, if I decide to change this, for example, I decide that heads should be lowercase, well, now I only have to change it in one place, and it will be changed everywhere properly. Okay, so I've now overridden my inherited toString method from the object class, so I'm going to go back and I'm going to rerun my program. Notice this time, my initial value simply says tails again. Well, what does this mean? What are the implications of this? Well, for one thing, it means right here, I don't have to say getCurrentFace anymore. Is there any difference between saying myCoin and getCurrentFace? No, you might even make the argument that saying getCurrentFace makes it much more clear and that I should leave it in there because the code is much easier and clearer. And that's fine. Now, what would happen if I actually wanted my toString method to be different than my getCurrentFace? So I'm going to go to coin, and I'm going to modify my toString here just temporarily to say the coin is showing, and then getCurrentFace. Okay, so now when I run this, and you know what? Let's do this. Let's make our initial value show getCurrentFace, and down here we'll just print myCoin. So up here, when we call getCurrentFace, we're actually going to just see heads or tails, which makes sense because initial value equals, and then we want to see the result. Down here, where we're printing the object, we'll see some nice formatted text. And now you can see the difference between those two methods and why you want to write your toString method in a nice, convenient way. It gives you, the programmer, control over how your object is displayed. Okay, well, that brings us to the end of part 1 of day 2 of the Randomizer project. We've discussed overloading, or rather overriding, inherited methods.